In this video, we want to discuss transformations. This is a way for us to quickly graph some functions if we just know a few rules and our basic underlying functions. So I would expect you to know y equals x squared is a parabola shape going through 0, 0, 1, 1, 2, 4. That y equals x cubed is that kind of curvy snake or sideways S shape that goes through negative 1, 1, negative 1, negative 1, 0, 0, 1, 1. That y equals the square root of x is a half parabola, and it goes through 0, 0, 1, 1, and 4, 2. And then that we have the absolute value of x, which is a V-shaped that goes through 0, 0, 1, 1, 2, 2, and its symmetric points on the other side. If you can get those four in your head and a few rules for transformations, you'll be able to quickly sketch graphs without having to plot points, do calculations, or even grab the calculator. Let's take a look at the rules. So the first one that we want to talk about is a vertical transformation. So you can see I have three parabolas graphed here, and they're kind of moved up and down from the green one. The one thing that we notice that's different in these equations is, well, this one has a plus 2, this one doesn't have anything, and this has a minus 3. If you're looking here, you notice that the blue one is moved up 2, the red one's moved down 3. That matches the equations. So in general, we would say that if I have my function, whatever it is, and then I'm like, let's add or subtract something, I'm going to be moving it up or down. And it moves exactly the way I would expect. In other words, if we add something, it'll move it up, and if we subtract something, it'll move it down. Let's take a look at another type of transformation, that is the horizontal kind, side to side. So once again, we're going to start with y equals 3x squared. But this time, if you look at our functions here, you'll notice that I have the plus 2 and then I square it, or I have the minus 2 and then we square it. So it's before we do our main function. That produces a horizontal shift. The tricky part here is if you look at this red one, this is where we did minus 2, but you notice it moved forward. So this one kind of goes opposite the way you would expect it to. If you have f of x plus or minus something, you change it inside of the function and then you do your function, you're going to get a backwards or leftward shift if you add, and you'll get something moving forward or to the right if you subtract a value. Two more. If I put a minus in my function, that's going to change it as well, and it depends on where I put the minus on how it changes it. So if I have the square root of x, which is that half parabola, and I put the minus on the outside, well, it's outside, it's a vertical change, and it flips it vertically so that it's actually upside down. If instead I put it on the inside, that's a horizontal change, so the flip this time is a horizontal one across the y-axis. The general rule then for us is that if I have a negative, whatever my function is, it flips it upside down, turns it over the y-axis. If I do f of a negative, I put that minus in the function before I do it, that's going to change it sideways, horizontally. Last one. We can also change it by multiplying. So if I have f of x equals x squared, I get my normal parabola. If I multiply it by 3, I also have a parabola, but it's a lot skinnier. And if I multiply it by 1/3, it's a parabola, but it's kind of fat. So the thing that's going on here is when you multiply it by a number greater than 1, you're stretching it like you do a rubber band. If you multiply it by something between 0 and 1, you're going to be fattening it or shrinking it, we say. Kind of think about that marshmallow inside the 2 graham crackers. When you press down, you're shrinking the distance, but it's widening the marshmallow out. Okay, let's see it in practice. Here is a problem where I have f of x is equal to the quantity of x plus 1 squared minus 3. I don't want to plot points. I don't want to grab the calculator. I just want to look at this and say, okay, it's a square function, so I know here's my black basic parabola. The inside part here says you're changing it horizontally. Because it's a plus, I know horizontal is the weird one. It's actually going to move it backwards. So here I kind of lightly sketched in green what it would look like if I just took every one of those black points and moved them backward one. And then the minus 3 is on the outside. That's the vertical shift. So it's going to take this green and shift every one of those points down. All right, so let me give you a specific example. Instead of going through 0, 0, I'm going to go back 1 and then down 3. Instead of going through 1, 1, I'm going to go back 1 and down 3. That's all you have to do to get the graph. Way faster than some of our other methods. Let's take a look at one more. This one is the square root, so it's the half parabola, x minus 2, and then a plus 1. Well, once again, I sketched my basic function in black, and then I ask myself the inside part, okay, minus 2, that's inside, that's horizontal, that actually goes forward 2 units, and then this is plus 1, so it's going to go up 1. So I'm going to start with my 0, 0, go forward 2 and up 1. That's now where my parabola or my half parabola is going to start. 1, 1, go forward 2 and up 1. 4, 2, go forward 2 and up 1. I've got my graph. Let me know if you have any questions.